Hi students, welcome back to the channel. So coming back to the topic, that is scheduling algorithms in operating system. So in this lecture number 28, we are going to cover round robin scheduling algorithm that is very important for your college level और university level examination. हर एक examination में ज़रूर इस topic में से question पूछा जाता है. So we will start with the introduction of this particular algorithm, its characteristics, disadvantages and advantages we will discuss. After that, I will share with you one important practice question from previous year examination. So let's start the introduction part. Remember one point, round robin scheduling algorithm is nothing but it is the preemptive type of first come first serve algorithm. We have discussed this already. So, round robin scheduling is fair in that every process gets an equal share of CPU. Here, let's say we have three processes P1, P2, and P3. Every process shares equal CPU. That means what? That means in case of round robin scheduling algorithm, there is fixed amount of time for every process, that is called the time quantum. So this is the keyword for round robin. Whenever in any question there is given any time quantum, let's say 2, 3, 4, 5, anything, that means the question is all about round robin algorithm. Okay. Out of some important scheduling algorithms, round robin algorithm is much efficient, but its efficiency fairly depends on the chosen time quantum. So we will discuss everything one by one with some example. Okay, so this algorithm is very special. Why? Because it is going to remove all the flaws which we have detected in previous CPU process scheduling algorithm. All the flaws that we have detected in first come first serve algorithm, the round robin algorithm is there to remove all those points. Okay, it is preemptive, so that means it is stoppable. And the reason behind the preemptive nature of this algorithm is the given time quantum. Okay, so let's just talk about some advantages, disadvantages and characteristics. So first advantage, you can write a fair amount of CPU allocation. A fair amount of CPU allocation is there. That is the time quantum. Okay. Second advantage is because it does not depend on burst time. This is the advantage. Does not depends on burst time. It can truly be implemented in the system. Okay. And its disadvantages are low operating system slicing is there. Low operating system slicing is there, that will result in decreased CPU output. Okay, and the procedures cannot have priorities established in this case. So all these are some advantages and disadvantages of using round robin scheduling algorithm. Okay, remember one point, whenever we want to use the this type of algorithm, it always focus on the ready queue. Its focus is always on ready queue. Okay, अभी तक हमने जितने भी स्केड्यूलिंग एल्गोरिथम्स पढ़े हैं वहां पर हम डायरेक्टली क्या करते हैं, इस तरीके से गैंट चार्ट बनाते हैं. बट इन केस ऑफ राउंड रॉबिन, first you need to create a ready queue. All the processes are ready to the added to the ready queue. At first, the burst time of every process is compared to the time quantum of the CPU. So here we have one example, but before moving to the example, let's just talk about some characteristics. Okay, so round robin scheduling in any operating system is clock driven. It is a clock driven algorithm. We can also say it as it always follows a hybrid model. Okay. Second characteristic here, clock driven means the time quantum. It always follow a particular time. अपनी तरफ से ये कुछ भी काम नहीं करता. It is a preemptive type of algorithm. That means we can stop any process in between and start running another process. Next is the round robin algorithm generally focus on time sharing techniques. It focus on time sharing techniques, and it is widely used algorithm in traditional operating system. ट्रेडिशनल ऑपरेटिंग सिस्टम्स में इसको बहुत ज़्यादा डिटेल में यूज़ किया जाता था. एंड रियल टाइम जितने भी हमारे पास रियल टाइम ऑपरेटिंग सिस्टम्स हैं, रियल टाइम मशीनरीज है, दे ऑल always follows what they always follow the round robin scheduling algorithm. Okay, I hope everything is clear till now. Now let's just move to the example here. So this question is from previous year examination. Here you can see time quantum 2 is given. Time quantum 2 unit is given here. Process ID, arrival time and burst time is also given here. As I have told you, round robin scheduling algorithm is the algorithm that does not directly focus on the burst time. It always focus on the given time quantum. Okay. So for this algorithm, first what you need to do, you just need to create one ready queue. Okay, so you need to create one ready queue here, and along with the ready queue, always remember to create one Gantt chart. अगर आपकी रेडी क्यू सही बनती है तो डेफिनेटली आपका Gantt चार्ट सही बनता चलेगा. So first you can start from arrival time, that is 0. So at a point 0, process P1 is arriving like this. Okay, so in the ready queue, first of all, we have added process P1. Process P1 wants CPU for 5 seconds or for 5 units. But according to the question, we can only allot any process to CPU just for 2 units. That means for 2 units only, from 0 to 2, process P1 is running. Okay, so here we have process P1 that is running from 0 to 2, but it wants CPU for 5 seconds. So 5 minus 2 is 3. That means 3 units are left. इसको एक एग्जाम्पल के साथ लेते हैं. मान लीजिए कि आपको 10 मिनट का काम है, लेकिन आपको 5 मिनट के लिए मैंने अपना कंप्यूटर सिस्टम यूज करने के लिए दे दिया. 5 मिनट के लिए दे दिया तो अभी आपके 5 मिनट का काम बाकी है ना, तो आप उसको बाद में कर लोगे. तो वही चीज राउंड रॉबिन में होती है. एंड इन द नेक्स्ट स्टेप, रिमेंबर वन पॉइंट, जब तक आपका प्रोसेस 0 से 2 के बीच में रन हो रहा था, प्रोसेस P1 जब तक 0 से 2 के बीच में रन हो रहा था, तब तक आप देख सकते हो 0 से 2 यानी कि टिल 2 वी हैव two more processes, process P2 and process P3. So जब तक 0 से 2 के बीच में process P1 रन हो रहा था, उतनी देर में प्रोसेस P2 एंड प्रोसेस P3 रेडी क्यू में रेडी हो रहे हैं, अपने एग्जीक्यूशन के लिए वो लाइन में लग रहे हैं. ओके, सो अब देखो प्रोसेस P3 तक तो यहाँ पर ये क्या कर गए, रेडी क्यू में ऐड हो गए. लेकिन प्रोसेस P1 क्या है, अभी भी कंप्लीटली एग्जीक्यूट नहीं हुआ है. कंप्लीटली एग्जीक्यूट नहीं हुआ है मतलब इसको घूमकर वापस क्यू में लगना पड़ेगा. तो अगेन यहाँ पर प्रोसेस P1 को क्यू में ऐड कर दिया गया है. ओके, इतना कर लेते हैं. सो अब हमें क्या करना है, प्रोसेस P1 को रेडी से गैंट चार्ट पे शिफ्ट करना है. इट इज रनिंग हियर. एट नेक्स्ट पॉइंट, shift process P2 from ready queue to running queue. So process P2 wants CPU for 3 units, but it is allowed 2 units only. ठीक है, that means 1 unit is left here. So process P2 from 2 to 4. Next point here is, जब तक हमारा प्रोसेस P2 0 से 4 के बीच में रन हो रहा था, तब तक अराइवल टाइम देखो 3 और 4 है, मतलब जब तक प्रोसेस P2 रन हो रहा था, तब तक प्रोसेसेस ये दो जो हैं, ये भी रेडी क्यू में ऐड हो चुके हैं। ठीक है, सो प्रोसेस P1 के बाद जब तक प्रोसेस P2 रेडी हो रहा था, अराइवल टाइम 4 तक के यूनिट्स भी ऐड हो जाएंगे। सो प्रोसेस P1 के बाद आ गया प्रोसेस P4, then we have process P5 in the ready queue. Again we are running in process P2, but process P2 completely execute नहीं हुआ है, इसमें 1 unit बाकी है। So for 1 unit again we will add process P2 here. Okay, so after P2 shift process P3 here, process P3 wants CPU for 1 second only. ठीक है, that means from 4 to 5. So process P3 is executed completely, so you can remove it like this. Okay, next we have process P1. Process P1 is left with 3 points. Okay, again यहाँ पर हमें CPU सिर्फ 2 seconds के लिए मिल रहा है, so 3 minus 2, यहाँ पर 2 seconds के लिए ये रन हो गया, 5 plus 2 7। ठीक है, एक लेफ्ट है, 3 कट कर अभी हमारे पास सिर्फ एक पॉइंट यहाँ पर बाकी रह गया है। P2 के बाद एक पॉइंट बाकी रह गया P1 का, so we will add P1 here in ready queue. Okay, so after completion of P1, let's just move P4 here. P4 wants CPU for 2 seconds, so it is executed completely. 7 plus 2 is 9. Okay, then we have process P5 here. So process P5 wants CPU for 3 seconds. P5, but we allow it for 2 seconds only, so 9 plus 2 is 11 here. Okay, so here means 1 is left, so इसको हम क्या करेंगे, वापस से process P5 को ready queue में add कर देंगे. Okay, now we have again process P2. Process P2 wants now CPU just for 1 second. So 12 ये भी completely execute हो चुका है, ये भी completely execute हो चुका है, and ये भी हो चुका है। ठीक है, then we have here we have process P2, then we have process P1. So P1 is left with 1 point only, so that is 13. So process P1 is also completely executed. Then we are left with only process P5, and P5 is left with only 1, that is 14. So this is how you can create a Gantt chart using round robin scheduling algorithm. This is one of the most important type of algorithm. Examination में sure question आएगा, बहुत easy है. You just need to practice it once or twice. Okay, so this is the Gantt chart, and with the help of Gantt chart you can find out the completion time of all the processes. Practice this question, this is very easy. You can see here we have the ready queue, we have the Gantt chart formula, you already know. Okay, so on the basis of the formula, exit time means completion time. Okay, this is the completion time, turnaround time, and waiting time. So you can check here. Okay, so I hope everything is clear till now. If you have any doubt, you can comment below. I will definitely help you. So thanks everyone for watching the session.